Hello everybody and welcome back to my channel. In this tutorial, I'm going to show you how to analyze beams and hence draw shear force and bending moment diagrams. This is one of the most important concepts in civil and structural engineering, as the concept is going to help you in various design procedures and other analytical aspects in civil engineering. I'm going to make 4 different tutorials with different examples to aid you in understanding this concept. The examples will have various levels of technicality, varying from the simplest to the most complex. With all that said, let's get right into our first example. As you can see, we have a beam, and the question says, analyze the beam below and hence draw the shear force and bending moment diagram. You have a simply supported beam with us, and it is loaded mid-span, at the mid-span, with a point load. So we shall start. We shall say summation of moments due to support A should be equal to 0. This means that total clockwise moment should be equal to total anti-clockwise moment. So we shall have, and we shall assume that we don't have support beam, and say we only have support A. So the forces that are going to cause clockwise movement at support A will be 60 times the distance, that is 3 meters, should be equal to the anti-clockwise moment. Anti-clockwise moment shall be at the point where we shall have reaction force at B, since the force is going to go upwards and it's going to cause an anti-clockwise moment. So we shall take, should be equal to 6 meters times the reaction force at B. So we shall have 180 kilonewton meter should be equal to 6 RB meters. So we want to find RB. RB is equal to 180 kilonewton meter over 6 RB meter. The meter is going to cancel with the meter. Sorry, 6 meter. Yeah, the meter is going to cancel with the meter. Shall have 1, and 6 goes into 180 30 times. So we shall say RB is equal to 30 kilonewton. At this stage, we can go and find the reaction force at A by using the second equation for static equilibrium, which states that summation of forces along the y-axis should be equal to 0, meaning total upward forces is equal to total downward forces. So RA plus 30 kilonewton, which is RB, should be equal to 60 kilonewton. That 60 is the downward force there. So we shall say RA is equal to 60 minus 30. RA is also equal to 30 kilonewton. With all that done, we can now go ahead and draw the shear force diagram. I had already prepared the place I'm going to draw my shear force diagram. So we found that Rn, the reaction force at A, is 30 kilonewton. We are going to assume that our 30 kilonewton is somewhere here, and we are going to mark it 30 kilonewton. This force is going to travel parallel to the 0 kilonewton line up to the point we have the 60 kilonewton force going downward. So we have 30 and we take away 60, so we shall have 30 minus 60 because we have a downward force. So we shall have 30 minus 60, which is going to give us negative 30. So negative 30, say negative 30 will be somewhere here. So we have negative 30 kilonewton. So the force here is 60. Coming from 30 to negative 30, we shall have 60. Then we have this force is going to travel also parallel to the zero line up to the point we shall have reaction force at B. So we are at negative 30 kilonewtons. This is negative 30 kilonewtons, but we are going upwards, force of 30 kilonewton. So we shall go upward 30 kilonewtons. So we shall have negative 30 minus 30 plus 30, sorry, negative 30 plus 30, which will bring us back to 0. Please do note that the figures above the 0 mark on the shear force diagram are positive. These are positive. And the figures below the 0 mark on the shear force diagram are negative. These are negative. Some people may go ahead and shade it, but it's okay. You can leave it at this point. Now we are good to go. We can now draw the bending moment diagram. To draw the bending moment diagram, we usually find the area of the shear force diagram. So we usually start from the 0 mark, and the area we shall say 30 times 3, which is 90 kilonewton meter. That is the bending moment for this valve, but it is on the positive side. For the bending moment, our positive side will be on the lower part. So we shall have here 90 kilonewton meter. So our 90 kilonewton meter is going to be at this point. 90 kilonewton meter, sorry. So usually we draw this using a slanted line. Because that is a point load. So this side is positive, as you can see here. And we now want to draw the bending moment for this other diagram. So we shall have 30, we shall take negative 30 times 3. You are going to get negative 90 kilonewton meters. So we shall say 90 times minus 90, minus 90 kilonewton meter. It is going to bring us back to 0 here. So 90, draw that, join the 2 to the 0 mark. As I had said earlier, the figure on the lower side of the bending moment diagram is usually a positive. So you can label this side to be positive. I think we are done at that point. I think you will be able to get all the marks for us at this stage. Thank you for watching. Please remember to like and subscribe to the channel.